In this example, we're given a circuit that has a bunch of inductors, capacitors, and resistors, and we're being asked to compute V naught of t, given that it's driven by this voltage source in here, which is actually a sinusoid. So let me just write in here, what we have is the following. We have the frequency at which this sinusoid is operational at is 5 radians per second. Okay, and now we're going to convert everything in terms of capacitors and inductors to their equivalent impedances. So for capacitors, it will be 1 divided by j omega, which is 5 times C. For inductors, it will be j omega, which is 5 n times L. Okay, so I'll go ahead and just basically substitute each by its value. So for example, we'll start with this here. This stays as 6. What about this one here? Well, this one here will be, I'll just substitute the C by 0.05, okay, and that value will be, let me just write it here. Okay, that value would be, instead of that, it will be negative 4J, and the V of S here, instead of V of S, becomes 50. This is the magnitude, and the phase is 0. And what about the 4 ohms in here? Well, it stays the same. This stays the same as 2 ohms. So what about the inductor in here? Well, the inductor is basically here. I'll have to substitute this by 2. So this here is just simply J times 10, or 10J. Okay. And what else do we have? We have this inductor in here. So the inductor will have to substitute this by 1. So this one here becomes 5J. Okay. And so let me just write them all consistent. So this is 10J. Okay, what about the resistors stay the same, nothing changed. What about this one here? So substitute 0.2 times 5, that's 1 divided by J, so this here must be negative J. Okay, so I think we got everything. This is negative J, 5J is correct, 3 and 5, 2, and this is 50. And this, well, here is what we're looking for, and of course it's not V naught of t, it becomes V uppercase V because we will be finding the phasor representation of this V naught. Okay, so there's multiple ways to do that. Let me just clean this figure a little bit so that we can do the computation a little bit easier. Right, and that's what we're left with. Okay, so let's do that here. So there's multiple ways we can figure out this V naught, and I think the way I'm going to do it is by keeping this 4 ohm alone, and then I'll combine all the other impedances together, like all of them. For example, these will be in series, these will be in series, the combination will be in parallel, and then in series with that too. And then whatever we get from this side will be in parallel from whatever we get from this side, and then we can apply voltage division for that. So let me walk you through this process in here. So what we will have is on this side in here, let me just zoom it out a little bit. So on this side in here, what we will have is this impedance in here, that's the source. Okay, the source is 50 and the phase is 0 degrees, and then this one here, we're going to keep it as 4 ohms. We can represent that's here. Okay, the combination of all of these here together is basically, I believe it's 6 plus 6J, 6 plus 6J ohms. And on the other side in here, what we have is the following. So we can figure out what these two in parallel are. These are basically, let me just write it in here and I'll give you the final answer. This is basically 3 minus J in parallel with a 5 plus 5J. Okay, and the whole thing will be in series with 2. Okay, so we need to figure out what these two in parallel are and then in series. Okay, so let me just do that. So as it turns out to be that the whole thing in here will be just simply 4.5 ohms. Alright, so now what's left? We're going to keep this source in here. This is 50. I can zoom out a little bit now. 0. And then we're going to keep this one here as 4 ohms. And of course, what we're looking for is the following, plus minus V naught. Alright, and then here is this impedance. So the impedance is pretty much 4.5 in parallel with a 6 plus 6J. And the answer will be, I believe it will be 3.046 plus 0.831J ohms. Okay, so now we can apply voltage division to figure out what this is. Like if you want me to rearrange it, it's fine. Let me just do that so that you can see it. What we're looking for is this impedance that we just found and the resistance in here, and what we're looking for is the following. We're looking for plus and minus, and this is V naught. Alright, so what V naught is will be negative 50. That's 0 in here times 4. This is the impedance I'm interested in, divided by 4 plus that's 3.046 plus 0.831J. and those are in ohms, so let's compute this value. So that answer will be 28.19, and the phase angle is 173.27 degrees. So that's V naught in the phasor domain. What we're interested in is V naught of t in the time domain, and that's simply 28.9 cosine omega. What was omega? That was 5, okay? So that will be 5 of t plus 173.27 degrees, and that's in volts.